In the last section, we talked about congruent triangles and basically said that if two triangles have all of their corresponding angles in common, and all of their corresponding sides in common, then the triangles are congruent. So if we wanted to prove that two triangles were congruent, we could show all 6 of these things were congruent between the triangles. However, that's a lot of work, and there are some shortcuts that we can take. If we have two triangles, and we can show that they have 3 sides in common between them, then we really don't need to show anything about the angles. They have to be congruent at that point, and we can stop there. Also, if we have two triangles that have 2 sides in common, and then this is really important, the angle that is in between the 2 sides, if they also have that in common, then the 2 triangles are congruent. We can stop there. We don't need to show anything else. Now, it has to be the angle that's right in between the 2 sides, so it can't be one of the outside angles like this one here. Can't be that one of those. Otherwise, we don't know for sure that the triangles would be congruent. And so these first 2 theorems I just talked about, first one is side, side, side theorem. The second one is side, angle, side theorem, and you can abbreviate them as I've shown here and here. If you're using these as a reason for 2 triangles being congruent, you can just write the letters. So also, if we have 2 triangles that have 2 angles in common, and the side that is right in between those 2 angles, they also have that in common, then they have angle side angle congruence. And then lastly, if we have 2 triangles that have, again, 2 angles in common, and then a side that is not right in between the 2 angles, then they have angle side congruence. Now, our book has some special theorems to prove that 2 right triangles are congruent. For instance, this one here, leg, leg, if we have 2 triangles, 2 right triangles, that have both of their legs in common, then the book says that that is leg-leg congruence. But you might notice that this actually looks like side, angle, side, and it is. So it's kind of redundant for us to try to memorize something like leg, leg when we can already use side, angle, side. So what I'm going to do is I'm going to actually not have you memorize these last 3. So you can cross those off. But the first one, hypotenuse leg, that one doesn't have a counterpart from the previous slide. So we should know that one because it's an extra tool at our disposal. So if we have 2 triangles, 2 right triangles, with their hypotenuse in common, and then one of the legs in common, then they have hypotenuse leg congruence. And so that's one that we want to remember. Now you might see a problem like this where it asks you if there was another triangle with these same dimensions, would these two triangles be congruent for sure? So you might just see one triangle drawn, but what the question is asking is if there's another triangle with the same dimensions that are labeled. So also a 7 centimeter side, then an 80-degree angle, then an 8 centimeter side. You're going to think back to the theorems we just talked about and see if one of them is represented here. Now, we basically have side, angle, side here. So we would say yes, these two triangles would have to be congruent, and it's because of side, angle, side. Here's another example. So if there were another triangle with these same dimensions, would they have to be congruent for sure? And none of the congruence theorems are demonstrated here. So you would just say, no, these aren't necessarily congruent, and you don't need to name any theorem or anything like that. You may also see a problem like this, where the two triangles are both drawn and the dimensions aren't explicitly given, but some of the parts are marked congruent. And you'll be asked, are the two triangles congruent? And right now it looks like we don't have enough information because there's only two sides marked congruent. We don't have the third side or any angles. So it looks like we might say no. However, these two triangles literally share a side. So we can actually mark that congruent between them. We have a very good reason. We know for sure that they have that side in common because they physically share it. So once we mark that, we can see that, yes, these are congruent by side, side, side. Here's another example where it looks like we might not have enough information to determine if the two triangles are necessarily congruent. We only have two sides labeled again. However, these two triangles are sharing vertical angles, and we know that vertical angles are congruent. So we have a really good reason for adding our own mark here. And now we can see, yes, these triangles are congruent because of side, angle, side. Now we can only add marks if we have a really good reason for putting them. We can't just haphazardly mark things congruent just because they look congruent. We have to have valid theorems such as vertical angles are congruent in order to mark things congruent.